Now that we're all finished with integration, I figured it was time that we put together a little review. So for this video, I'm going to be giving you some questions, and I would expect you to work those out on your own. So the question will appear on your screen. Take a few seconds to work it out, hit pause, and then when you're ready for the answer, you can resume the video, and you can see me working out the question. Here's question number 1. Please integrate the following trinomial. At this point, you'd like to hit pause, and then when you're ready, resume the video. And this one's pretty straightforward. So for your answer for this trinomial, there's no need for any substitution. All you have to do is add 1 to each of the exponents, and then divide by that new exponent. So for x to the negative 4, I add 1 to get negative 3. I then divide by negative 3, which is the same thing as multiplying by negative 1/3. Add a square to the x and divide by that square. 2 divided by 2 is 1. Add an x to the constant, and don't forget plus c, and you're all set. Question 2. Please integrate the following function. At this point, you'd want to hit pause. And here's your answer. For the first part, I'm going to go ahead and rewrite the function 4x to the 1/2. I then want to add 1 to the exponent. 1/2 plus 2/2 is 3/2. Divide by that 3/2, which is the same thing as multiplying by 2/3. Clean this up a little bit. 2/3 times 4 is 8/3. 8/3 x to the 3/2 plus your constant. Question number 3. Solve the differential equation. For the first step, I'm putting 5x minus 2 raised to the 4th over 1 so that I can cross multiply. dy times 1 is dy, and dx times the expression. And now we're going to integrate both sides. When I integrate dy, I get y. And for the right side of the equation, you could probably work that out in your head if you wanted to, but I'm going to go ahead and do substitution. I'm going to let u equal 5x minus 2. The derivative of that is 5 dx. I do not have a 5 dx. I have a 1 dx, so I divide by 5 or multiply by 1/5. I substitute everything out in orange. The 1/5 du goes in for dx. I'm going to put the 1/5 out front and make it u to the 4th. Multiply 1/5 times 1/5 and back substitute for u. So here's your answer in green, and if you take the derivative of green, you'll get the original question back up in 3. Let's just check. 5 times 1/25 is 1/5 times 5x minus 2 raised to the 4th. And then you have the chain rule. You're going to multiply by the derivative of everything in parentheses. The derivative of 5x minus 2 is 5. 5 times our 1/5 turns into the 1, and we've got it. Question 4, solve the differential equation given the following conditions. AKA, we're going to solve for c. I'll give you a second. First, I'm going to cross multiply, setting dy equal, and then I'm going to integrate. Adding 1 to each of my exponents, and then dividing by that new exponent. Keeping in mind, dividing by is the same thing as multiplying by the reciprocal. Now I'm going to substitute in my y equals negative 2 and my x equals 0 to solve for c. 0 cancels out, 0 cancels out, c equals negative 2. Now rewrite the expression. And your final answer in blue. Question number 5. Please integrate the following. If you needed a hint, I'm going to let u equal the following trinomial. Now take the derivative, hit pause, and see if you can't get any further if you didn't know what to do for the first step. The derivative of u is 2x plus 2. I do not have a 2x plus 2. I can factor out the 2. This is now looking closer to what I had. I'm going to divide both sides by 2. And now I'm ready to substitute everything out of the expression. 1/2 is going to go out front. Take the integral of u squared. X plus 1 dx swaps out for du. Add 1 to the exponent, divide by that 3, same as multiply by a third. Don't forget the 1/2 that was already out there. Back substitute for u, got your answer. Question 6, here you go. There's a hint for you. Taking the derivative, I get -3. I have a 12 in the numerator. I'm going to want to go ahead and multiply both sides by -4. And now substitute. -4 goes out front. Instead of 1 over u squared, I'm going to make that u to the -2. Now add 1 to the exponent and divide by that. Adding 1 to the -2 in the exponent makes that -1. Divide -1 by -4 makes that +4. Back substitute for u. And your final answer is in orange. Question 7. For your u substitution, if you want to let it 1 plus x to the third, taking the derivative, 1/3 du, I need that 1/3 out front because I only have an x squared in the numerator. So if at any point you're not sure how to do these problems and you're stuck, please don't watch me do everything. Just try to take some hints here, then pause and try to finish the problem on your own, then double check with me. Now I'm ready to substitute everything. If you find it helpful to rewrite this one, instead of square root, raise it to the 1/2, and then bring it to the numerator, feel free to do that. My u substitution in red. Adding 1 to the exponent, -1/2 plus 2/2 is +1/2. Multiply by the reciprocal 2. 2 times a third is 2/3, and then back substitute for c. Now you can always take the derivative of my final answer here, and I should be able to get the original question. Question 8, here's your first one involving trig. There's a little hint for you. Taking the derivative, you get 3x squared. We want to make that 1/3 du. And time for substitution. The x squared and the dx swapped out for 1/3 du, and the x cubed plus 1 swapped out for u. The integral of cosine is sine, and then at the same time I'm just going to go ahead and swap out the u for my x third plus 1 plus c. Done. Here's question 9. Your first hint if you need one. Be careful here taking the derivative of cosine 2y. The derivative of cosine is negative sine, so it's negative sine 2y. Then I have to multiply that by the chain rule. The derivative of 2y is 2. So you get -2 sine 2y dy. In the problem, I have a sine 2y, so I'm going to divide by that -2 and start substituting. Now I'm letting u equal cosine 2y. So that square is staying there. and now it's becoming u squared. Add 1 to the u, divide by that, don't forget about your negative 1/2, back substitute for u, and you're finished. Your final answer, if it's u cubed, we're swapping that out with cosine of 2y, making it cosine cubed of 2y. We are not cubing the 2y, we're cubing the trig function cosine. Question 10. You will not need substitution on this one, so here's your first hint. I'm going to rewrite it like you see in red. One over cosine squared is secant squared, and I asked you to memorize the integral of secant squared as tangent. Your final answer is tangent theta plus c. No need for substitution, just use some properties to rewrite it, get it into a format that I know. Question 11. If you're having trouble with this one, try to keep in mind the Pythagorean identity, tan squared equals secant squared minus 1. So using that identity, I'm getting rid of tan squared and writing it as secant squared minus 1. The square root of x, I'm rewriting as x to the positive 1/2. The square root of x in the denominator, I'm writing as multiplying that times x to the negative 1/2. Now it's time for substitution. I'm going to let u equal x to the 1/2. Take the derivative of x to the 1/2. 1/2 comes down in front. Take 1 away. I do have an x to the negative 1/2 times dx. I need to get rid of that 1/2, so I multiply both sides of that expression times 2. And now x to the negative 1/2 dx is going to swap out with 2 du. And secant squared x to the 1/2 minus 1, the x to the 1/2 is going to swap out with a u. The integral of secant squared is tangent of u. The integral of minus 1 is negative 1u. Don't forget your constant. Don't forget the 2 out front. 2 times tangent, swapping out u for x to the 1/2, minus, don't forget to distribute 2 to the negative 1u, negative 2u, u is x to the 1/2, plus c. Again, that negative 2 attached to the x to the 1/2 came from distributing 2 to tangent and 2 to negative 1u. 2 times negative 1 is negative 2. U is x to the 1/2. Final answer at the very bottom. Here's question 12. In this one, I would let u equal x squared. The derivative of x squared is 2x dx. Convenient, you have 2x directly in front. After you substitute, you get e to the u. U was your x squared. 2x went out with du. The integral of e to anything is e to anything. So e to the u plus c. And then just rewrite it. U was x squared plus your constant. Here's question 13. Hope that's not too blurry for you. There's your hint. I would let u equal e to the x. The derivative of e to the x is e to the x. I do have an e to the x, but it's multiplied by 4, so I multiply the entire expression times 4, making it 4 du. And now my substitution. 4 goes out front. Then just take the integral of sine u. That's going to be negative cosine u. And instead of cosine u, I'm just going to skip right to the chase there. Cosine e to the x, it was negative, makes it negative 4, plus your constant. Question 14. Hint for you. Derivative of ln x is 1 over x. If you're still not seeing it, let me take a second to go ahead and separate that function so maybe it'll jump out to you. I'm going to replace the square root with raising ln x to the 1/2. And instead of putting that over top of x, I'll write it to the side times 1 over x. Now you should be able to see your substitution pretty easily. It's just going to be u to the 1/2 du. When I integrate this, I'm going to add 1 to the exponent, divide by the reciprocal. And get rid of the u, replacing it with ln x. Question 15. If you can't read that, it's x times 3 raised to the x squared. Here's your first hint. Let u equal x squared. Du is going to be the derivative of x squared, which is 2x. I don't have a 2x, I have a 1x. So I divide by the 2. I do have an x dx. Now do my substitution. Instead of 3 to the x squared, it's 3 to the u. And for this integral, it's going to be 1/2 times the integral of 3 to the u. That's going to be 3 to the u, and then divide by the ln of 3. Now, if you recall, the derivative of 3 to the x is ln 3 times 3 to the x. So I multiplied by ln of 3 when I was taking the derivative. The reverse process for this, which is the integral, would be dividing by the ln of 3. Don't forget about your constant. And you might want to put some brackets around here just so we don't get too messed up. And then swap out the u with x squared. So let me just write that down. If I gave you 3 to the x and asked for the derivative, it's the ln of the base times the function. So when I'm asking you for the integral, I'm going to keep it 3 to the u, but now instead of multiplying by that ln of 3, I divide by the chain. Question 16. I wouldn't jump directly into substitution quite yet. I would go ahead and rewrite this one, separating sine over cosine squared into multiplying by 1 over cosine. Sine over cosine is tangent. 1 over cosine is secant. Now my substitution of u equaling 2x. If u equals 2x, du is going to be 2 dx. I don't have a 2 dx, I have a 1 dx. I divide by the 2. And substitute out these 2 x's for my u's. Put a 1/2 out in front. And the integral of tangent secant should look familiar to you by now. We've done that enough times. That's one of the ones you have to memorize. The integral of tangent secant is secant of u plus c. Swap out the u for the 2x, and you're set. Okay, if a equals 10t minus 2, a is acceleration. I want you to find the velocity function v of t and the position function s of t. Under the conditions that when velocity is 5 and position is 1, that happens when time equals 0. Just a reminder, a is acceleration. Acceleration is dv dt. If you're wondering what to do, I'll tell you that you're going to have to integrate twice. Integrating for the first time, that's not going to work. You don't have dt on the right side, so let's rewrite that one. Let's divide by that, or cross multiply rather. Get my dt's with my t's. Now integrate. That's going to give me the velocity function. Add 1 to the exponent t squared, divide 10 by that. Add a variable to the 2, plus my first constant. So now I have a function for velocity in terms of c. I want to get rid of that c. So I said at time 0, this is a function v of t. I'm going to evaluate that v of 0, and that is equal to 5. So plugging in 0 for all my times, that goes away, that one goes away. You're left with c1 equals 5. Now you have your velocity function. Velocity is the derivative of position, so v of t equals ds dt. I'm going to integrate this function again, but first I'm cross-multiplying to get the dt's over with the t's. So let me rewrite all that. You can see all that in green at the top. Now integrate. When I integrate ds, I get s position. The trinomial, add 1 to the t, makes it t squared, divide by it. Add 1 to the t. Oh, sorry about that. I messed up in my original one. I didn't copy that down right. That's 5t squared. So that should have been a squared up top. So that really makes that when I add 1, it's going to be a 3, and 5 divided by the 3. Glad I caught myself there instead of waiting till the end. Adding 1 to the t here makes that t squared. 2 divided by 2 is negative 1. Plus add a t to the 5 plus a second constant, which I want to solve for. So now, when s equals 1, time was 0. So that's a function in orange here for s of t, position. I plug in 0 for all the times, and a 1 for s. Goes away, goes away, goes away, and you're left with c1 equals 1. Now you have your function for s of t. So my original equation or question said find s of t, the position function, and find v of t, the velocity. I have both of those. I got the velocity function by integrating the first time, substituting everything in to solve for the constant. I then integrated for a second time to get the position function and substituted everything in to solve for the second constant. Let's bring it back to all the business stuff that we did a little bit earlier in the year. I got Nike, which has marginal costs, and I want to know the cost of producing 100 units and the actual cost function. Marginal cost is C prime, and I gave that to you in the first sentence. To get the cost function, if I'm giving you the derivative, you just integrate it. When I integrate C prime, I get C of x. Integrating 65, I add a variable. I add a square to the x, and I divide by that square plus a constant. I now need to find the value of that constant. I do that by substituting in the cost of producing 2 units is 135. So producing 2 units, C of 2, I put a 2 in everywhere I see x in the orange equation, and work all that out and solve for C1. Okay, I was told that the cost was 135. I plugged in a 2 times 65, I got 130. 2 squared multiplied by that decimal width fraction, I get negative 0.1. and then just simply 130 minus 0.1, take it to the other side, and you solve for C1. So I will have C1 is 5.1. Now I have my cost function. And I'm going to clean up the negative 0.05 divided by 2, calling it negative 0.025. If I want to know the cost of producing 100 units, I just simply find the C of 100. Everywhere I see an X in this equation, I plug in a 100 and simplify. You should get $6,385. Hopefully you remembered some of that marginal cost stuff from way back when, and now you can see how that applies with integrals. Previously, I would have given you the cost function and asked you for the derivative, marginal cost. This time we're just working backwards. So that's it. Hopefully you found those 18 problems helpful. You know, if you didn't, you can watch it as many times as you want. This should be a good review for your test coming up fairly soon. See ya.